In this experiment, we're going to look at the reaction of the decomposition of hydrogen peroxide to water and oxygen. Hydrogen peroxide usually decomposes on its own very slowly over time. To help reduce this, we often store it in a brown bottle. So there's our brown bottle of hydrogen peroxide, and keep it at a room temperature or lower to make sure that the decomposition is a slow reaction. The hydrogen peroxide we're going to be using in this experiment is a 3% solution, just like you might buy at your local drugstore. And if we want to study this reaction, we're going to want it to be faster. So we're going to add potassium iodide, which acts as a catalyst and increases the speed of the decomposition reaction. So those are our two reactants, is hydrogen peroxide and potassium iodide. And we're going to go ahead and get these ready to react, and we want to ensure that they are at the same temperature. So Andrew is going to take 4 milliliters of hydrogen peroxide. To do that, he's using a graduated cylinder with about 9.5 milliliters of hydrogen peroxide. He's going to put that into a test tube and until he brings this volume down to 5.5. At that point here, he has added 4 milliliters of the hydrogen peroxide. And he's going to put a little cork in this. We've lost our cork at the moment. There it is. And then he's going to put this into a water bath. And this just ensures that the hydrogen peroxide is at the same temperature of the water bath. And we previously have set this water bath to be at room temperature, which is what, Andrew?
21.9 degrees Celsius.
21.9 degrees Celsius. Now we need our other reactant, our potassium iodide. We need 1 milliliter of this for our first run. In subsequent experiments, you'll be changing the amount of potassium iodide or the amount of hydrogen peroxide to see the effective concentration. So Andrew, on this plastic pipette, has some markings on it. He's going to drop 1 milliliter and flip it over so all the potassium iodide is in the tip or bulb. And he's going to put that into that water bath there as well. And put the cap back on our potassium iodide. Check our water bath temperature.
21.9 degrees Celsius.
21.9. So it didn't really change. We think everything is at room temperature. So this looks good. And now what we're going to do is collect the pressure change after we mix these two reactants. When we mix them, the reaction will go faster. We'll generate a lot of oxygen gas, which will increase the pressure, and we should be able to record that pressure increase. To do so, we're going to look at a little pressure sensor. So Andrew's going to hold that up. This pressure sensor has a tube coming out of it, and it terminates on this stopper, and the stopper has a hole in it. And so that's open to the atmosphere right now, and air from the atmosphere is traveling through that tube and pressing on a diaphragm in the pressure sensor, which translates it into an electrical signal and sends it over to the iPad. And what is the pressure at the moment?
0.991 ATM.
0.991. So essentially 1 atmosphere. That's our pressure in the room here today. So Andrew's going to go ahead and hit collect. And what this is going to do is it's going to collect the pressure of the room as a baseline. And Andrew's going to take our hydrogen peroxide in our test tube. And then he's going to take our potassium iodide. And he's going to mix the two. And he's going to swirl it for about 5 seconds. And then he's going to put the stopper from the pressure sensor on. And we'll be able to collect that pressure sensor. And you may notice as he's doing that, that's probably good. Put the stopper on nice and tight here. And you can see on our graph that we're getting a pressure change, and you can also see in our solution it's turning yellow and it has a lot of bubbles going on. Okay, and I'm going to zoom in on this graph here. And Andrew, you want to hit the auto scale there. Okay, and you can see that we instantly got a large pressure increase. And Andrew, you want to hold that stopper down a bit. There we go. Sometimes the stopper doesn't sit very well and we have to hold it in place. Now we're starting to see quite a rise. And this initial rise in pressure here is, as our reaction is going, we're creating more and more oxygen in our tube, and that is increasing the pressure in our test tube. This looks to be going pretty well here. gonna go to about 200 seconds or so. Poor Andrew's got to hold this here. Sometimes the test tubes and the stoppers don't always sit very well, and you have to hold them in place. Okay, but you can see that we have a nice rise in temperature. The first part of this, we saw a very sharp initial rise in pressure, and then it leveled off a bit because we were leaking a little bit out of our stopper, and once Andrew's been holding it in place, we've been getting a pretty steady rise in pressure. And that's all we need. We need to know a little bit about the change in pressure over time. And so what we're going to do here in just a little bit is stop the experiment. Actually, we're going to go ahead and stop it now because I think we've got enough data at this point. And what we're going to do is we're going to select a portion where the graph was clearly increasing in pressure there for about 30 to 50 seconds or so. And then Andrew's going to fit this to a line, so he's going to do a curve fit. And the slope of this line represents how quickly the pressure was increasing, which represents how quickly the reaction was going. And this particular graph here in our video is not one we're going to use. We're going to give you data, but this illustrates how that data is collected. And then you're going to use the slopes of these initial rates of the change in pressure over change in time to analyze the rate of the reaction.